Good Monday morning. Today we're doing 14-5, writing to explain one of my actually kind of favorite lessons of the year. Just makes you use a different part of your brain. So this graph is showing a little graph of Lynn's trip. You got time going across the bottom, and you have the distance from her house going up the left side. So the question is what the heck is this grid showing us? Now, what most people get kind of right away, I need a pointer of some sort, is here when she's at 0 minutes and 0 blocks from her house, she's obviously at her house. And then as she goes up, to point B, she took 5 minutes to travel 4 blocks away from her house. And then what happened there? Getting to point C. This is one area where kids don't quite get it, and they think like, oh, well, she walked some more. Well, she's back to 0 blocks from her house. She walked home right there. This is where kids go, what? But home's over here. No, anywhere along this bottom line is she's home. So she's at home. She walks 2 blocks away. She walks 2 blocks back. Remember, this is the distance from her house as we go up. And we're coming back to the house as she comes down. Time is going this way, so there's no way she can time travel backwards to where she was. This is her house. So here she goes and she walks for a much longer period. What happens from D to E? What do you think that's showing you? This is one area where kids get a little freaked out. She is staying 8 blocks away. Maybe she's at a playground, maybe she's at a friend's house, whatever. She's just staying there. So at 20 minutes, she's 8 blocks away from her house. At 30 minutes, she is still 8 blocks away from her house. Maybe she's talking to a friend, whatever it is, but she's not traveling anywhere. And then E to F, she's coming back home. We have a similar one down here with one added little bit. So distance from home in miles, so instead of blocks, it's miles, big deal. And you got time going across the bottom. A to B, who is this here? We don't know. Jim. This is Jim. Jim went biking. Jim traveled 1 mile in 10 minutes. And then, going from B to C, he traveled an additional 2 miles. Now he's 3 miles away from his house. And that took him another 10 minutes. Now, during what portion of his trip was he going the fastest? A to B or B to C? And what you have to look at is the slope of the line. The slope here is steeper. This means he is going faster. Here the slope is not as steep. He's not going as fast. And if you look at the time, it makes sense. He went 1 mile in 10 minutes. And then in these 10 minutes, he actually went 2 miles. So he was going twice as fast right here. What happened from C to D? Just like Lynn's trip up above, he just hung out at that spot. So at the 3 mile mark, he took a rest for 5 minutes and didn't go anywhere. And then what about his trip home was different than his trip to wherever it was that he went. He rode home at the exact same speed. So he did not travel slowly at first and then sped up at the second part. He just went fast. He went the same speed all the way home. So the slope can tell you how fast that they are going. That is it. There's really no other tricks besides that. If you just take a couple of extra seconds and think about what chart is showing you, you can probably figure out any old question that they throw your way. I am looking for my teacher's edition so that I can give you the homework. Oh, goodness. Hold on. Right here on top. Alright, homework pages. You have 14.4 tonight. Sorry, 14.5. Writing to explain. Here is reteach. Here is practice.